Lesson 66. Let's look at finding the area of polygons in perimeter, regular polygons. We have a couple of definitions we're going to need to look at first before we move on to the areas. First one is the central angle in a polygon. Well, central angle, we've seen that before. We've seen that from a circle. And if you remember, in a circle, a central angle was the angle between two radius, but the radius both intersect at the center, okay, like radius do. Central angle in a polygon is the same thing. It's lines from the vertices to the center of the polygon. So if we have a pentagon, and say it's a regular pentagon, then we actually know that all the central angles are congruent. But that's what a central angle is. The next definition we need to look at is an apothem. This is a new one. Y'all haven't heard this word before. What an apothem is the perpendicular distance in a regular polygon from the center to a side. So we have a regular polygon. This line is from the center, and it makes a perpendicular line to the center of the side, thus being at the midpoint and creating congruent side lengths here. But this is our apothem. Does not connect with the vertex, but midpoint of a side and is perpendicular. So now that we know what an apothem is, we can look at our area formula for a polygon. How you find the area for a polygon is doing the area equals 1/2 apothem, is what the little a stands for, times perimeter. The big P stands for perimeter, and perimeter is easy to solve for these regular polygons. So example 2, it wants us to find the area. Well, in 1/2, we take our apothem. It makes it easy on us here and says 18. So 1/2 times 18. Now we need to find our perimeter. So to find our perimeter, we do 15 times the number of sides. Number of sides is 8. So 15 times 8 is 120. And when we multiply all that together, we would get area equals 1080. And since it's area, it's inches squared. That's a very basic problem. You're not going to get them quite that easy. But let's look at example 3, where it gets a little bit trickier. It says find the apothem of this regular hexagon. Okay, well, we look at what we know. We have a side length of 10 centimeters. If we know one side, and it's a regular polygon, then we can figure out the perimeter. Perimeter would be 10 times the number of sides. Number of sides is 6. So perimeter equals 60. So that's part of it. Now we need to find the apothem. Well, here's our apothem. Now, how do we find that if it hasn't given it to us? Well, what you got to kind of do here is think outside the box and create a triangle. Now, when I create this triangle, what I've actually done is this angle here is a central angle. Central angle. We know that all central angles are congruent, and back in investigation 3, way long ago, to find a central angle in a regular polygon, what we did was the formula of 360 divided by the number of sides. Well, the number of sides here is 6, so 360 divided by 6 is 60. Thus, our central angle is 60. Now that we know that, what I want to do, I want to cut a triangle in half here. I'm going to move this triangle right here. Now, what do we know about this triangle? Well, if we knew this whole angle was 60, and that this apothem bisects the angle, the central angle, well, then that would mean this angle is half, aka 30. That's 30. We know this is a right triangle because it's perpendicular, and triangle sum theorem states that this would be 60. Now we're trying to find our apothem, but do we know any of the side lengths? Well, we can't say we know the hypotenuse necessarily, but we do actually know the short side, because 10 is a side length. When we cut this triangle of the whole base, when we cut this base in half, that would make our base of this triangle 5. And now we can use 30, 60, 90 triangle principles to figure out our apothem. And to get from a short side to a long side, you remember all we did was multiply our short side by radical 3. So therefore, our apothem is 5 radical 3. And now in our formula of 1/2 apothem times perimeter, we have both of them, so we plug it in. 1/2 5 radical 3 times 60. 1/2 of 60 is 30 times 5 radical 3. 30 times 5 is 150, and then we leave the radical 3, whatever my measurement is, centimeters squared. 150 radical 3 centimeters squared. So it all goes back to creating that triangle, that imaginary triangle, when we're solving for areas in these apothems. One more example, example 4. It wants us to find the area of this triangle. And it gives us a regular triangle here. So formula for area of a triangle is 1/2 base times height, but we don't know the base or height. So therefore we cannot do that. Well, actually, not true. We do know the base. Base is 18. But we don't know the height. So what we're going to do is our formula. We do know the perimeter. Perimeter is 18 times number of sides, 3. 18 times 3 is 54. Thus our perimeter. Now we need the apothem. Well, just like the last one, how we created a little triangle, we're going to do the same thing here to figure out our apothem. Because here's our apothem, right angle, and I'm going to create it with this triangle. Well, hopefully you know that in an equilateral triangle, all angles are 60. So what I did, I cut this triangle in half, and if I cut this 60 degrees in half, that means it is now 30. This is 90, that is 60. We know our total base here was 18, so we cut that in half to be 9, and we're finding A. So now we actually got to go from a long side to a short side. Well, short side to a long side is multiplied by radical 3. Long side to short, we are going to divide by radical 3. Get rid of the radical in the denominator to get an apothem of 9 radical 3 over 3. Oh, we can actually reduce that a little bit. 9 and 3 can reduce to 3 over 1. So 3 radical 3 is our apothem. Plug it into our formula. Area equals 1/2 3 radical 3 times 54. I'm going to do 1/2 of 54, 27. And then 27 times 3 is 81. My measurement, I do not know, inches. And so you do area of regular polygons and find the apothem.